Well, hello everyone. Gary here. I'm going to start part 5 um, of the roguelike tutorial in Rust. Um, so if we recall in the last video, we left off with a fairly simple random map generator. Um, move our character around this little map. Uh, and we can't walk through walls and stuff. And the walls are just kind of randomly positioned throughout the world. So, um, today, or well, this video, we're going to start chapter 4, a more interesting map, and actually generate a map worth using, hopefully, by the end of this. First things first, it looks like the project is getting big enough where even the tutorial writer's like, hey, let's go clean things up. Um, and I completely agree with this. This is a very messy layout. So yes, let's go clean this up. I'm gonna actually dig into their source code for this chapter and see how they got things organized and try to mirror that. So it looks like they got cargo toml here, and then they have their source folder. That's fine, and they have a few files. Um, I have components, rs. They have app player and rect, which I'm not going to create that file yet because I don't remember messing anything with rectangles yet. So um, let's go in here and see how they've got this laid out. So they have components. Looks like that's in the top here. Anything that derives component um, goes here. Looks like we need to have a few imports here. Specs, prelude, everything. Use specs derive and use RLTK RGB. And it looks like all of these need to be marked as public. So pub position, renderable, and then player. And how are they resolving these dependencies? .rs looks like they're just doing this here. And let's see if we can still build. Use specs derive, could not find derive. Components rs specs. Oops. Yep, that's typo. Sorry about. Font card type inside a component rs. Line 13. RLTK. Okay, yeah. Because I'm not importing that, and I kind of went off the beaten path for their project. And all right, so it looks like position X, Y, FGBG glyph is not available. It looks like these are okay. So we need to make extensive use of the pub keyword here. Okay, I didn't place that. Okay, that should be fine. Let's see if this builds. Sure does. Okay, one of the other things I wanted to kind of point out here is in C-based languages, your if statements and stuff like that. See if I can find one. Um, where's a good? Okay, yeah, your if statements. They generally have parentheses around the condition, and I'm used to doing that, and I'm not going to move away from that for Rust. So the compiler always throws a warning if you have it. So I added that line here. I went and Googled, added this line, and it removes the warning from the compiler. Um, so, anywho, still kind of being hard-headed as far as that's concerned, just because I work in so many different languages, and every other language actually forces me to have those parentheses there, and yeah, it's just habit. All right, so the next thing here is we want to, so pub enum tile type. Looks like that's coming from map. And then we have our ID, XYIDX stuff as well. This needs to be marked as pub. Anything that you want to be accessed outside of this file, you need to mark it as pub. So pub. And I don't know if, yeah, it looks like the XYIDX, yeah, it's already marked as pub from the last video. And that's not functions we've written already. Draw map. That we should have a function. Yeah, here's that function draw map. Draw map. And we should be able to main RS. I'm going to group these together. Can I not? Okay, it's just already named. Map. I'm going to put my public. So the idea here is I'm kind of keeping organized. So any kind of modules that I'm declaring here, I'm putting at the top. Then I'm putting my local module use statements right underneath that, and then any kind of package or crates use that I'm doing here. I think that should theoretically still compile. Let's make sure. Pub func draw map, RLTK is not found. Okay, yeah, I need to do my imports. That's fine. So use RLTK GB TK and random number generator. Use super. We're actually not going to do that, and because we haven't written the code for that yet. std cmp min max. Okay, cool. Let's run this real quick. Let's see if it runs. Sure does. We still get the same program. Perfect. And all of our player functions need to be moved into this player.rs file. So here we go. We use RLTK virtual key code RLTK use specs pre all. We haven't done anything with superposition or anything like that. And use std cmp max. And we'll just, so here's our player input and try move player. Okay, so main is 2. Because pub. And in main rs. Yeah, there's nothing. We need to thing player player. Okay, that should be good. Player input. Let's see if it compiles and runs. All right. Tile type. It looks like yeah, we need to import this super. I think. We'll see what happens. So we have position, player, tile type, XYIDX, and state. Okay. Now can we run it? Private type state. This is can't leave private type. I think it's this is line 6 player input GS. State RLTK source main 15 struct state declared as private. Oh, okay. Pub. Perfect. Yep, we still get a compile, and let's make sure that what's left in main here is the same. So we have our pub struct state run systems. Actually, we need to do a self.ecs.maintain. We removed that earlier. This is a bug probably. It really isn't apparent. It doesn't seem. And then we have our game state. Yep, that's right. And then we have our main function here. One of the things I want to do before we get into their stuff, and I don't know if it actually to it. Okay, yeah, wrapping up. Okay, so it's kind of gets into this a little bit. So I'm actually going to wait until we get there. I know I skimmed through it and I saw it in the when we were reorganizing this player RS, right? The virtual key codes. I want to WASD support those keys for player movement. Okay, so now we are a little bit more organized. Our main RS is about as organized as it's going to get for now. I would like to move this game state stuff out of main.rs, but we'll deal with that later. Alright, it says making a more interesting map. We'll start by renaming new map in map.rs. Okay, to new map test, just to keep it around. We'll stop using it, but we'll keep it around. It's a decent way to test our map code. We'll also use Rust documentation tags to publish what this function does in case we forget later. Okay, so I'm just going to copy that. And canonical Rust, if you prefix a function with comments starting with triple slashes, it makes it into a function comment. Your IDE will then show your comment text when you hover over function header. Okay. You can then use Cargo's documentation features to make pretty documentation pages for the system you're writing. It's mostly handy if you plan on sharing your code or working with others, but it's nice to have. So now, in the spirit of original lib COD tutorial, we'll start making a map. Our goal is to randomly place rooms and join them together with corridors. Making a couple of rectangular rooms. We'll start with a new function. Okay. Let's create a new function. This is going to be a pub fn new map and corridors. Oops, I'm so used to writing in different languages. Tile type. Let mute map equal vec. Tile type. And 80 by 50 or 4000. And we're going to return. All right, so This makes a solid 80 by 50 map with walls on all tiles. You can't move. We kept the function signature, so changing uh, the map we want to use in main RS just requires changing um, with this. So if we go back to main RS, that insert call, if we run it now, we should just have a solid screen. We cannot move, none of our key presses work, so perfect. Once again, we're using the vec macro to make our life easier. See the previous chapter for discussion on how that works. Since our algorithm makes heavy use of rectangles and rect type and a rect type, we'll start by making one in rect.rs. We'll include some utility functions that will be useful later in this chapter. Okay. So let's create a new Rust file, rect.rs. And we're going to create a few things. Bob struct rect, Bob x1, b2, x2, I32, Bob y1, b2, and Bob y2, bi32. Perfect. Going to impl rect. So we're going to create an implementation of rect. We'll say pub fn new x I32 y2 w I32. Oops. I'm not used to these type names. I just want integer, double, float. So x, y, width. Be more descriptive of your variable names, guys. Even like in this tutorial, I can't stand x, y. That's coordinates. That's fine. But wh, that's not descriptive at all. Your variables should be self-descriptive. No matter what language you're working in, that's so annoying. So without further ado, width, height, and we'll say rect. Yeah, we're gonna return a rect, right? And we're gonna return rect. And x1, x, y, x2, x plus width, and y2, x plus height. Format some code there. Okay, cool. And so this is our generator function for a new rectangle. Pub fun intersect takes a self other, and that should be rect. And this should return a bool, right? So we'll say return self dot x1 is greater than or equal to other dot x2, right? And again, chaining these on one line of code benefits no one. So and self dot x2 greater than or equal to other dot x1, and we'll do and self dot y1 Bet this is okay. Yeah. Other dot y2 and self dot y2 is greater than or equal to other dot y1. Okay, cool. And then pub function center, and this should be self, right? Take self, and it should return back a tuple of i32s. Return self. Added. So this is parameter A and parameter B. Right. So self dot x1 plus self dot x2 divided by 2, and self dot y1 plus self dot y2 divided by 2. Okay, that's easy enough. There's nothing really new here, but let's break it down a bit. We define rect, a struct called rect, and we add a pub tag to make it public. It's available outside of our module. By putting it into a new file, we automatically create a code module. That's a built-in Rust way of compartmentalizing your code. Over in main.rs, we can add pub mod rect to say we use rect, and because we put pub in front of anything, we can get rect from use as super rect. Okay, it's not very ergonomic to type. The second line we use rect that shortens the super rect. Okay, we'll make a new constructor entitled new. It uses the return shorthand and returns a rectangle based off the x, y, width, and height we pass in. We define a member method intersect that has self, meaning it can see the rect to which it's attached, but we can modify it. It's a pure function. It returns bool, true, if the two rectangles overlap, false otherwise. We define center, also a pure member method. It simply returns the coordinates of the middle of the rectangle as a tuple, x and y. We'll also make a new function to apply a room to a map. Okay, so if we go back over to map.rs, we should be able to import the super, I forget what the syntax is. Yeah, it's just use super. We probably need to go into main.rs. Don't think we actually use it, but we need to declare the module at least. And then now over here, I think that makes it to where we can actually use. Well, doesn't give me my autocomplete, but I imagine that this should theoretically allow me just to import it. Okay, so we go ahead and create a pub function, apply room to map. This is a rect map. This is a mutable reference title type, or a mutable. Why can we not use super? Maybe I have to actually use it here. Okay, yeah, I actually have to use it in main.rs. Okay, I didn't know that. New to Rust, guys. Okay, so here we're doing some loops, it looks like. So for y in room dot y1 plus 1 apparently dot dot equals room dot y2, and then for x in room dot x1 plus 1, right, dot dot room dot x2. Wasn't quite looking. And then map xy idx xy equals tile type floor. That looks good there. Notice that we're using y in room y plus 1, y2, that's an inclusive. Oh yeah, we need to make sure that we are doing that here as well. Can I separate these? Like, does it matter? Yeah, that's a little bit better, I guess. We want to go all the way to the value of y2 and not to y2 minus 1. Otherwise, it's relatively straightforward. Use 2 for loops to visit every tile inside of the room's rectangle and set that to a floor tile. With these 2 bits of code, we can create a new rectangle anywhere, rect new with height, and add it to the map as floors apply to room. Okay, that's enough to add a couple of test rooms to our map function. So we'll go ahead and do that. So here's that map. We'll say room 1 equal rect new 20, 15, 10, 15. Let room 2 go rect 5, 15, 10, 15. Apply to room. Apply room to map and room 1. And this will be a mutable reference that we're passing down. Map. And we're going to copy this function and change the room number. Now, does this run? Sure does. We have 2 rooms. That nice. Making a corridor. So if you cargo run your project, you'll see that we have two rooms not linked together. They are together. Oh, I did 30. Okay. Whoops. Try that again. $35, 15, 10, 15. 20, 15, 10, 15. And it's line 54, 29. X and Y. I believe it's an 80 by 50. 35, 15. Because we're going out of bounds. Down to 10, 25, because we're going out of bounds. Why are we going out of two different size rooms? These shouldn't be 2 different sizes. Should have a 10 by 15 room. at our rect. We have x's, x, y, x width. Oh, that's why. This is why. Run this now. Do we get? Oh, okay. Yeah, there we go. And then we should be able to change our map back. So 25, 35. Back to what they originally had planned for us. That's fine. Hey, look, I can walk around the room. I cannot. Okay. Perfect. Making a corridor. Two disconnected rooms isn't much fun. So let's add a corridor between them. We're going to need some comparison functions. So we're gonna have to tell. So we have to tell Rust to import them at the top of map.rs. Use standard min max. We've already got that. Min and max do what they say. They return the minimum and maximum of two values. You could use if statements to do the same thing, but computers will optimize this into a simple fast call for you. We let Rust figure that out. Then we need to make two functions for horizontal and vertical tunnels. Okay. So we'll do pub fn apply horizontal tunnel. We need a map, which will be a mutable reference to title type, or of a list of title types, basically. Vector x1 bi32 2 i32 and then y. All right, so for x in min x1 x2 x x1 at idx equal xy idx xy if idx is less than or greater than 0 and idx is greater than 80 times 50. Map idx as usize tile type. Okay, so it's fairly simple. I'm going to assume doing the same thing for y-axis, right? So let's just apply tunnel vertical, and then this takes in a y1, oops, y1, y2, x, and it says for y, 1, y2, y1, y2, takes in an x and a y, and an idx. I think that should be get code fragment 6 lines long. I don't think so. Well, theoretically, yes. But it should be fine. Then we can add a call to apply a horizontal tunnel mutable map 24, 40, 23 to our map making function, and voila. we have a tunnel between two rooms. If you run cargo run this project, I can walk between the two rooms and not into walls. So our previous code is still working, but now it looks a little bit more roguelike. All right, so yeah, let's do that. So we'll pass in the mutable map 25, 40. Yep, mutable. Actually, that in right there. If we run that, sure enough, we do have our tunnel. We can pass through from room to room. Everyone is happy. Alright, making a simple dungeon. Now we can use that to make a random dungeon. We'll modify our function as follows. New map, rooms, and corridor. Alright, so we have a mutable map, which is the 80 by 50 walls. And we'll say let mutable rooms. It looks like we're just going to clear all this out. Let mute rooms equal, this is going to be a vec of rectangles equals vec const max rooms equal 30, 32, const min size 32 equals 6, const max size I32 equals 10. 6 by 10s. Let mute RNG equal random generator new for Lodash and 0 max rooms. Let equal number generator dot range min size. And we'll do the same thing for this needs to width, height. Don't like that. WH syntax. Let x equal RNG dot roll dice. One 80 minus width minus 1. Y equal RNG. Roll dice. 150 minus height minus 1 minus 1. Okay. Let new room equal rect new. And this will be x, y, width, height. Let mute okay equal true. For other room and rooms dot iter if new room dot intersect other room okay, equals false. I have a feeling that this is a return. Oh no, no, that's the body of the if statement. That's very strange. Okay, and then if okay, apply room to map room and a mutable and then rooms dot push. Okay, we return the map. Now it says there's a quite a bit changed here. We've added we added constants for the maximum number of rooms to make, the minimum and maximum size of the rooms, and this is the first time we've encountered const that just says set up this value at the beginning and it can never change. That's fine. It's just like that in most languages. It's the only easy way to have global variables in Rust since they can never change or often don't even exist and get baked into the functions where we use them. If they do exist, because they can't change, there is no concerns when multiple threads access them. It's often cleaner to set up named constant than use a magic number that is hard-coded value with no real clue of why you picked that value. We require random number generator from RLTK, which required that we add use statement at the top. Okay. We're randomly building a width and a height. Then we're placing the room randomly so that x and y are greater than 0 and less than the maximum map size minus 1. We iterate through the existing rooms, rejecting the new room if it overlaps with one we've already placed. If it's okay, we apply the room. We're keeping rooms in vector, although we aren't using it yet. Okay, so yeah, this is fine, I guess. And if we run this, we have some randomly placed rooms. I would be interested. Yeah, it's looking like the way that his is they're not allowed to overlap at all. I like the way that this works though, because you can actually have a room with odd shapes and sizes and stuff, which is pretty nice. Okay. You should now get something like this when you. Okay, this is okay. Joining the rooms together. We now need to join rooms together with corridors. We'll add this. So I'm thinking that their rect function is returning something a little bit different than what mine is. So x1 greater than or equal to other x2. Okay. And this is x2. Oh, okay. See if that runs. Okay, yeah. Now see, I am not allowing intersections at all. Okay, yeah, it was right. Joining the rooms together. We now need to join the rooms together with corridors. We'll add this if the OK section of the map generator. So with the if OK, we'll go back to map.rs. And looks like it's before we push the rooms. So we'll say if not rooms is empty, let new x new y equal new room dot center prev x prev y equal new room our rooms dot length minus 1 dot center if rng dot range 0 comma 2 equals 1. Apply horizontal tunnel. This will be a mute. Map prev x, prev y, and then new x. And then of course the apply vertical tunnel. And that's prev y. Oh, this prev x, new x. And this is prev y, new y, right? New. And this is prev x. Prev. All right, else. And it says apply vertical tunnel. This apply new y prev x. Okay. It's just doing it the other way around, I guess. Don't know why. Can we run it? Let's see what happens. Okay. Interesting. All right, let's make sure this is right. Prev x, new x, prev y. And prev y, new y, prev x. This is horizontal, vertical, vertical, horizontal. Okay. Prev y, prev x, new x, new y. That makes things a little bit sane, I guess. Well, we have a double corridor. Always the center though. Cool though. So what does this do? It starts by looking to see if the rooms list is empty. If it is, then there's no previous rooms joined, so we ignore it. If it gets the room center and stores it new x and new y, it gets the previous room's vector center and stores it prev y, prev x. It rolls a dice, and half of the time it draws a horizontal and then a vertical line tunnel, and half of the time the other way around. Try cargo run now and it'll start looking like a roguelike. Okay. Placing the player. So I don't see the weird looking tunnel. Okay. Placing the player. Currently the player always starts in the center of the map, which with a new generator may not be a valid starting point. We could simply move the player to the center of the first room, but it's likely that our generator will need to know where all the rooms are so we can put things in them, rather than just the player's location. So we'll modify the new map rooms and corridors function to also return the room list, so we can we change the method signature to pub fn, and then we return the vector as a tuple, tile types and rect. All right, cool. So now we have that. And then the return statement to be rooms map. It's fine. Yeah, no complaints. Alright, our main.rs file also requires adjustments. To accept the new format, we change our main function, main.rs, to alright, so RLTK, RTK builder. Okay, yeah, we already have that. Context, build, yeah, let mutable game state. Okay, we are registering everything right after that. And then we have map equal, and then we do a this will be the map, and then we have let player X player Y equal rooms 0 center, and then play Y. Alright, now what happens when we run this? Our player is placed in the center of a room. It's rendered. I have a feeling that the center functions are just not returning correctly. I mean, it's returning. That's correct. Or maybe my X and Y. Correct. Okay. Okay. This is mostly the same, but we're receiving both the rooms list and map from the new map corridors when we place the player in the center of the first room, wrapping up and supporting numpad and VI keys. All right. Now that we have a map that looks like a roguelike, places the player in the first room and lets you explore with the cursor keys. Not every keyboard has cursor keys that are readily accessible. Some laptops require interesting key combinations for them. Lots of players like to steer with the numpad, but not every keyboard has those either, so we support the directional keys as well. So I'm not going to add every one of these keys. I'm literally going to put left or virtual key code. That's and we're going to do virtual key code, in this case, D. Virtual key code W. Virtual key code S. Now, can we run this? Can I use WSAD now? Can. All right. You should now get something like this when you're in cargo run. Yep. Okay. So, joining the rooms together. Let's go back over to map because I have a feeling that we're not doing this right. Okay. Apply room to map. That's fine. Rooms is empty. New X, new Y. Room, new room center. That's fine. Prev X, prev Y equals rooms. Rooms at length. -1 center. That's right. And then we say if random number generator range 0, 2 equals 1. I'm literally just going to copy this and see if there's a difference here. Like it. run it, see if it still looks the same. No, it doesn't. Something was different there. Sure what it was. It's a lot better. There we are. We have a functional roguelike. Or, not really functional. We have a map that has corridors and such now. Alright. Looks like in the next video we're going to be working on the field of view. So hopefully we can get something out the door. So yeah, this is so far this is actually a very fun series to be doing. It gives me something new to do, and it's so far it's just great. Um, Thank you guys for watching. Have a good rest of your day. Bye bye.